Back around the beginning of the new year, or very late in 2017, Harbor Freight Tools sent me a coupon which I could redeem to receive one of these light switch look-alike battery-powered chip-on-board LED lamps. These things are all over YouTube. They've been discussed by numerous other people who've said pretty much everything there is to say about them. And if you actually want to buy one, I suspect that all the regular suspects like eBay, Alibaba, AliExpress, even Banggood, whose name never stops being funny, and certainly physical brick-and-mortar stores like Harbor Freight have them, and they're pretty cheap. But I didn't really need anything like this, and so I just couldn't justify spending even a few dollars on one. I just really wasn't in the mood to buy one. But there are some things I can certainly always use, and as Harbor Freight requires that you purchase something to make use of a free item coupon, I simply got a hold of some alligator clip-style jumper leads, because you can never have too many of those. This particular light does actually come with the batteries installed, which is a remarkable departure from most of them that you'll see sold. And they are, as you'd expect, the anonymous Chinese carbon zinc or zinc chloride battery, usually sold under some sort of internationally unrenowned name like these that say Warriors. These are the ones that actually came with it. There's a dark joke in there somewhere about dead warriors, which of course they would be very soon. The amount of light put out by these things is simply enormous, and to get that kind of light, even with the high efficiency of an LED, out of especially a battery designed only for a low amount of current delivery like a carbon zinc or zinc chloride type, you're going to be beating them absolutely to death. They will not illuminate for very long. So I actually decided to take another tactic with this. You could use alkaline batteries and you'd get better current delivery from those, especially a proper name brand battery. Even a proper name brand carbon zinc battery would probably do better than the little anonymous Chinese ones, which incidentally are not the most hilariously named batteries I've actually found in any Harbor Freight product. That honor would actually go to the batteries that came in this little puck style light. They recently ran down after about a half an hour's worth of use. Malt Max. I kid you not. Of course, English is very frequently used, not for its actual meaning, but if we believe what we read on the internet, it's viewed as a marketing tool over there, so that's probably why the name doesn't make a whole heck of a lot of sense, because all it had to be was an interesting marketing vehicle. In any event, getting back to the subject at hand here, I decided to pull out the Warriors batteries and replace them with something else, something that was capable of delivering quite a bit more current than those puny little batteries could manage. And what you're looking at here are a total of 4 Rayovac AAA sized nickel metal hydride rechargeable batteries. And the thing about nickel metal and nickel cadmium rechargeable batteries, they laugh in the face of heavy loads such as this. But there was a drawback to this, which some of you have probably already noticed. They did actually put a series current limiting resistor in here, and when I put in some batteries that could no doubt stand up and laugh at the kind of current demands that undoubtedly drug the terminal voltage of these little Warriors brand batteries down quite a bit, the back of the switch, presumably where the current limiting resistor is located, got so hot that it melted. So it's probably not the best idea in the world to do that. I don't think it would actually catch on fire, but it did end up smelling very, very hot. Naturally, this made me quite curious to know just how much current is that little light actually pulling down, because it's very, very bright. Just watch what the camcorder does to compensate when I turn it on. It's practically blinding in real life. In fact, now that I can't see anything, that's pretty much where the video ends for today. Stay tuned tomorrow when hopefully I'll have my vision back and we can finish the test that I had in mind to make. Alright, so I'm actually kidding about that. We are actually going to make some tests here in this video. There are 2 tests that I'm curious about. First of all, I'd be interested to know just how hard it pulls down the terminal voltage of those nickel metal hydride batteries, which would tend to suggest that even they are probably being pushed to their limits. So we'll start with that test first. I've got the multimeter set up to read DC voltage here. Now all we have to do is just figure out how these were wired, and we'll take a guess here that this is probably the negative connection. All of these batteries are in series with one another to produce a higher terminal voltage. With alkalines, this would be right around, or actually a little bit above 6 volts DC from a fresh pair. these being rechargeable nickel metal hydride batteries with a terminal voltage of 1.2 volts apiece, it'll be slightly less. And indeed, we're reading about 5.5 volts there, so these are pretty much fully charged. However, they are not brand new batteries. I actually found these loitering in the dining room, several packages of them, which is part of what prompted this experiment, because I was trying to think of something that I could do with about 10,000 packages of nickel metal hydride AAA batteries. So let's turn the lamp on here. It's hauling down the terminal voltage on those pretty good. It dropped almost a complete volt. So they're definitely being loaded quite ferociously, which leads to the next question. Just how much are they being loaded down? Now, a person could take a resistance test and use Ohm's law to figure this, but if you know anything about me at all, you'll know that I'm the kind of person who believes very strongly in empirical results. Plus, it makes for great video making material, or so he said. So we need a few things in order to be able to determine how much current is actually being drawn by these LEDs if we're going to do the actual test. We'll need a multimeter with a current range suitable for testing DC amperes. And we also need some aluminum foil, which we have right here. I snaked that out of the kitchen. Whether or not I'll actually put it back before my mother notices is a matter of some debate. And then, of course, we need an insulating shim. And those of you out there in the viewing audience, if you can tell me what case of soda this came from, what brand of pop this was, well, I guess you win the internet for a day, because that's about the best prize that I have to give. So what we're going to do here is we're going to put foil on each side of this, stick it into the battery compartment, hook the multimeter's leads up so that it's in series, set it up for the amperes current measurement mode, and we'll be back with our results very quickly, thanks to the magic of video editing. Well, unfortunately, I think there's been a bit of a disaster. I went to test out my little circuit interrupting shim here so I could get a current reading, shorted across it with a jumper lead so as to complete the circuit just to verify that it would work, and all I got from this thing was a brief little flash of light, and now it seems to be completely dead to the world, even when I take the shim out of there. And I'm confident that these batteries are still good, so I think something in here has probably shuffled off its mortal coil and experienced a great brevity of existence. Not totally sure how this is meant to come apart. I took out the 4 screws around the perimeter and it loosened things up, but it's still not quite willing to come out just yet. So we'll try these 2 in the middle here, which really don't feel like they're in very good condition at all. Or rather, the plastic they go into is not really in very good condition anymore. And it's making a terrible popping noise, which probably suggests I'm about to break this thing beyond all repair. But it was free, so I guess I shouldn't complain. It would also beat those nickel metal hydride batteries down quite a bit. The light output would dim considerably after around half an hour of operation or so, or thereabouts. Alright, it's a little looser now than it was. So let's see what we've got here. They've got a little switch there. LEDs. I told all of you that I thought there was a limiting resistor in here, but I don't actually see one anywhere. Unless, of course, it's on the back side of this circuit board. Maybe this switch was such poor quality that it became the limiting resistor and is ultimately what failed. I think that's exactly what's happened here. Well, we can find out. We'll get a meter lead on each side of that with the help of our alligator clips that I bought at Harbor Freight. We'll switch to the audible continuity mode here, verify that it works. And we'll clip one side here. If this whole business doesn't fall apart, which it might. And let's see, where's a good place to get on board the other side? I was hoping I wouldn't have to clip directly to that solder point on the circuit board, but it's looking like I might have to do that. I'm just astounded that that little switch apparently couldn't live up to the demands that were being placed on it. Although I don't know that for sure yet, so let's just throw the switch here and see if we get a continuity beep. Well, we do. So if something shuffled off its mortal coil, it wasn't that. Alright, let's just see if there's continuity between the LED strips. Alright, we'll have to take this thing out of audible continuity mode because, as I remember, its resistance testing range is fairly limited in that mode. So we'll try it here. Alright, so either I've got reverse polarity, which it's looking like I do, so we'll swap that around. These are diodes after all. Nope, still open circuit. So I guess somehow or another, especially since there's no series limiting resistor in here like I thought there was, I must have killed the LED strips. And I think I might have, because looking at them right here and now, we'll try to zoom in on this with the scanning electron handycam so you can see what I see, assuming it will actually focus here. Look at those little dark spots. Now there's one there for every little die. At least I would assume that's every individual LED on that strip. I guess I burned them out by simply supplying them with too much electrical current. So in this case, Harbor Freight did a very cheap and nasty thing, or whoever manufactured this for them. I guess they made the assumption that everybody would be using these little carbon zinc or zinc chloride batteries that just can't supply that much electrical current, and certainly not for any length of time. And by doing so, they hoped to ensure, and probably did, that the LED chips would remain in their safe operating area. But when you hit them with a great deal more electrical current from a source whose voltage won't droop like those zinc chloride or carbon zinc batteries did, evidently you blow it up. I probably should have left this alone. After all, there's only so much time that it's worth putting into an item that's free. But the more and more I looked into this, the less and less likely it seemed that something had actually burned out. And I think that what I thought were burn marks are simply markings inside these LED chip-on-board assemblies that indicate where the individual LEDs actually are on the die. Not that they're burned out. They don't really look like they're particularly dark in color or anything like that. So I did one more test. When I stuck all the batteries back in here, put the multimeter on its DC volts measurement range, hooked up to these clip leads, and discovered that I had no voltage actually making it in here. And it wasn't a matter of it being loaded down as it might be in the case of a short circuit, because A, nothing was getting hot, and B, I turned the switch off and the result was the same. So this certainly needed a closer investigation, and after spending about 5 minutes looking at things, I found the problem. Here it is. If the Handycam would only decide to focus on this, that would be just absolutely glorious. Right here on this positive battery terminal, there was the slightest of a black mark. But non-conductive junk is non-conductive junk is non-conductive junk. So I scrubbed it off of there. When I put the batteries back in, it came roaring right back to life. Of course it made a fool of me. Well, we'll fiddle around with it a little bit here. There we go. It's definitely a case of bad electrical contact. And yes, there was another oversight on my part. There actually are current limiting series resistors in here. They're just surface mounted jobs on the back side of this board. I don't know how they ever expected those to stand up to the punishment. But there they are, right on the right-hand side of your picture. I'm tired of this camcorder thinking that focusing properly on subjects is something that only happens with other camcorders. So I was wrong about that as well, and you can all point and laugh in the comments as much as you like. So clearly what we were dealing with here was just a matter of dirty contacts. And now that we've got it going again, I guess we can do the test that I had originally planned to do, and then I can throw this whole mess back together and see if it might actually still work. Because if it does, obviously I haven't been fixing it nearly long enough yet. Alright, at long last we're finally ready to make our current draw test here. It only took about 1,000,000 years longer than it should have. As you can see, I've stuck in my little line splitter of sorts there, made out of aluminum foil. Got the multimeter leads hooked up to that. The multimeter itself is in the high current testing range, because when you're dealing with something whose values are uncertain, you should always start at the highest range and work down, especially when you're doing something like this, where the possibility of popping a fuse inside your meter is very real. So let's go ahead and throw these lights on and just see what kind of current we're pulling down there. Wow, over 3/4 of an amp. That's quite a bit of current draw. I'll let that sit and run for a while and just see how much it changes as things warm up, or maybe burn up in this case. And just for the sake of being thorough, on the left-hand side we have the meter measuring current, and then on the right-hand side we have the other meter measuring voltage. And if you do the math, that works out to 3.72 watts worth of electrical energy that's being consumed by those LEDs, which is certainly a pretty brave load for them to be carrying. Let's see if I can possibly get a lead, haha, pun most definitely not intended, on just how hot those series current limiting resistors are getting. And maybe the LEDs themselves. I've got another meter kitted out here with a thermocouple attached to it. So we'll go down here and we'll try to pick up one of those series limiting resistors. And the temperature is coming up fast. That's not even a very good connection, but it just keeps rising and rising and rising. Shows no sign of stopping, at least until I slipped off of it. I'm not real sure what the safe operating area for those resistors are, but I'd have to think we're getting close to it. Same thing in degrees Celsius. And since we're keeping tabs on things, let's just see what those LED chips are doing. Might have to wait a while for the temperature to come down, so I'll be right back. Well, the LEDs are certainly warm, but I definitely don't think they're in danger for their lives, unlike those current limiting resistors. Same thing again in degrees Celsius. Alright, well now I can definitely wrap up the video by saying thank you for watching. Please excuse the foibles that you saw. I could have reshot this and edited them all out, but that's just not the way I do things. Because I figure if one looks like a success all of the time, that just gets suspicious after a while. And as always, I await your constructive commentary.